Good day, everyone. How's your day?
We're fine. We're good, ate.
Okay, it's good to hear that we're all doing good. But before we proceed to our virtual discussion, let us first introduce ourselves so that we can communicate or interact properly. Okay, by the way, guys, my name is Rian May Sase, a fourth year student of BS Ed Science.
I am Cherry Paho from second year student from BSN Science 2.
Good day, ladies. I am Camille S. Caminos from BSN Sci 3 student.
Good morning, everyone. I am Arjun B. Barriado, a third-year student from BSN Science.
Good morning, everyone. I am Marjan Felix, third year student from BSN Science.
Okay, nice to know you guys. So, I have here the first question on our task. The first question is before we proceed, guys, I want you I want you all to share your ideas or your knowledge about the questions, okay? So the first question is how objects are charged. So, in my own based on my research, when electrons are added or taken away from an object, an electrical charge is produced. An object acquires a negative charge when electrons are introduced to it because electrons have a negative charge. So that is my opinion. How about the others? How about you, Camille?
Okay, based on my research, a charged object is any object hold a net of electric charge that have an equal number of positive and negative charges. In Coulomb's law, stated that electric charge can be transferred from one object to another. Charged objects can exert forces on other charged objects and uncharged objects. That's all. Thank you.
Thank you. How about you, Miss Cherry?
For me, how objects are charged. For me, an object gets a charge when it's rubbed. This rubbing causes the object to gain or lose electrons. When it loses electrons, it becomes positively charged. When an object gains electrons, it becomes negatively charged. There are three types of charge in objects. First, charging by friction. Second, charging by conduction. And third, charging by induction. Therefore, I include the charging in objects of three types. They are by friction, which can be done only through rubbing the material with another material. By conduction, which can be done by touching into a charged body, and by induction, which can be done without touching the charged body to the object they charge. Chargers move with an electric field from one position of electrical potential to another. They will move spontaneously through an electrical potential difference or voltage in whichever direction results in a decrease in the charge's electrical potential energy. That's all.
Okay, thank you. How about you, Argeline? What is your idea or your opinion?
So, according to my study, as what Ms. Cherry explained, there are two charging process by friction, by conduction, and by induction. So, in charging charging by friction, it is when two materials are rubbed together, the one material donates electrons to the other. And charging by conduction, conductors can be charged by touching. And charging by induction, the charged object is near but doesn't touch by a conductor. That's all.
Thank you and not. Thank you. And the last one we have here, Mary Jean. Can you share your opinion or idea?
How objects are charged? For me, an object gets charged when it is rubbed. This rubbing causes the object to gain or lose electrons. When it loses electrons, it becomes positively charged. When an object gains electrons, it becomes negatively charged. That's all for how objects are charged.
Okay, thank you everyone for the your wonderful ideas. Now let us proceed to the to number 2, the quantization and conservation of electric charge. So in my opinion, electron can radiate or absorb energy as radiation only in limited amounts or bundles. That is called quanta. So that's my opinion. How about you, Camille? What is your opinion on the question number 2?
So, based on my research, according to Hemant Moore 2020, the cause of the quantization of electric charge is due to the fact that when body is rubbed with the other, an integral number of electrons are transferred. All observable charges are always some integral multiples of elementary charge, where E is equal to 1.6 times 10 raised to the power of 19c is known as quantization, where n is equal to 123, where E is equal to 1.6 times 10 raised to the power of 19c is the magnitude of the lowest possible charge which is carried by an electron and proton. That's all. Thank you.
Thank you. How about you, Miss Argeline?
So, according to my research, quantization of charge implies that charge can assume only certain discrete values. And according to the law of conservation of charge, charges cannot be created nor destroyed, but can be transferred from one place to another. The total charge in a system must remain constant.
Thank you, Miss Argeline. And we have now here Miss Mary Jane. What is your idea or opinion? And question number 2.
According to my research, conservation of charge is the principle that the total of electric charge in an isolated system never changes with time in the universe or particular reaction. It comes under the three principles of charge, the other two being additivity of charge and quantization of charge. Conservation of charge means that charge is neither or created destroyed. The charged particles can be created subatomic level. That's all.
Okay,
Thank
thank
you.
you, Mary Jane. And the last one, we have here Cherry. Can you share your idea or opinion?
Okay, for me, conservation of charge is the principle that the total electric charge in insulated system never changes. The net quantity of electric charge, the amount of positive charge minus the amount of negative charge in the universe is always conserved. Therefore, I imply that electric charge is quantized, meaning that it occurs in discrete units. Quantization of charge is relevant only at the microscopic level because the transfer of electrons as a concept becomes irrelevant when we move to the macroscopic level because charges are considered to be continuous there. That's all.
Okay, thank you. I think we all understood. Are we're all good now. Okay, okay. So let's proceed to the second part of the task, the Venn diagram about the make a Venn diagram, compare and contrast the insulator and conductor. So what can you give me one of the characteristic of conductor, Miss Mary Jane?
The characteristic of conductor we have copper and silver.
Okay, how about the characteristic of, can you give me an example of one of can you give me an example of a characteristic of the insulator, Miss Cherry?
The characters of insulator, plastic or rubber.
Okay, thank you. Okay, Camille, what can you add? Can you add something?
Okay, based on Mary Jane, conductors are materials that permit electrons to flow freely from particle to particle. That Mary Jane discussed earlier, the example of conductors. And while insulator are materials that impede the free flow of electrons from atom to atom and molecule to molecule. That's what Cherry emphasized the example of insulator. Okay,
Okay,
that's all.
thank you. And how about their common, Miss Argeline?
So the similarities of course, both deals with electronic conductivity of a surface or material. So that's all.
Okay, may I add something? So, in the common of insulator and conductor is they are also can be placed in a circuit. So, are we done? Are we all good now?
Yes.
Yes po.
Okay. Pwede na ba natin i-end ang call? Ang meeting, I mean.
Yes. There
Okay.
is no clarifications or
Uh,
any questions.
yes. Do you have any question or clarifications? Or gusto nyo bang
None.
mai-add?
None so far.
Okay. So, I think dito na matatapos ang lahat. This will be the end of our discussion. So, thank you for your time. Thank you for all
Okay, thank you.
lending your ears and have a good day. Goodbye and God bless.
Goodbye
Thank you
everyone.
guys.
Bye.
Bye.